page 1-20. The Big Bang Never Happened, Eric J. Lerner, 1991. Preface to the Vintage Edition. 400 years ago Galileo broke the bonds that had entangled science with religion. Defying his fellow scientists' near unanimous commitment to Ptolemy's finite, Earth-centered universe, Galileo defended Corpernicus's unlimited, sun-centered cosmos. He argued that observation, not scientific or religious authority, must be the test of cosmological theory. Science and religion must be separate, he declared. Religion teaches how to go to heaven, not how the heavens go. But now, 4 centuries after the scientific revolution, we seem to have come full circle. Historic Big Bang discovery may prove God's existence, reads the headline of an Associated Press story dated April 25, 1992. Leading cosmologists are quoted as saying that recent astronomical discoveries are like looking at God, that they prove the reality of the Big Bang, a scientific version of the biblical story of creation. Cosmology again seems to be entangled with religion, at least in the headlines and in the minds of some cosmologists. To be sure, these newspaper headlines have told a confusing story. In January 1991 the headlines boldly stated that the idea of an explosive birth of the universe, the Big Bang, was dead. Big Bang theory goes bust, read one in the Washington Post. But in April 1992 another headline in the New York Times reported astronomers detect proof of Big Bang, a profound insight on how time began. What accounts for this sudden turnaround in the heavens? According to the reports, this decisive proof of the Big Bang, this scientific discovery of the century, of all time, this key evidence of the creation and of the deity, was the discovery of tiny ripples in the intensity of the microwave background, a sort of universal radio hiss. Thus, if we are to believe the reports, the finding of tiny fluctuations in the background radiation overshadows in importance the discovery of nuclear energy, DNA, antibiotics, the theory of relativity, and the quantum theory of matter, among other more minor scientific ideas. But reality is different from headlines. In fact, the overwhelming mass of scientific evidence still contradicts the Big Bang, as this book endeavors to show. As of this writing in May 1992, the Big Bang remains in just as deep trouble as ever, with even wider divergence from observation than when the first edition of this book was completed in late 1990. The blizzard of press releases that accompanied the discovery of these fluctuations by the Cosmological Background Explorer (COBE) satellite are not mere objective statements of fact but a salvo in the developing cosmological debate, a debate that is steadily growing and that has profound implications for science, and indeed for society. In the year and a half since this book was written, the evidence against the Big Bang has grown stronger, and the COBE results, far from proving the theory, have not in any way resolved the problems raised by other discoveries. The key problem, as I describe in Chapter 1, is that there are objects in the universe, huge conglomerations of galaxies that are simply too big to have formed in the time since the Big Bang, objects whose age is greater than the age Big Bang cosmologists assign to the universe itself. These conglomerations stretch over 1 billion light-years of space and were first discovered in 1986. In January 1991, while the first edition of this book was at press, a team of astronomers led by Will Saunders of Oxford unveiled a survey of galaxies that confirmed beyond all doubt the existence of these conglomerations, termed supercluster complexes. The survey, based on data from the infrared astronomical satellite, IRAS, showed how prevalent these large structures are. Since no version of the Big Bang predicted the existence of such vast structures, cosmologists viewed the new finding with alarm. It was this discovery that led to the widespread headlines in early 1991 that the Big Bang theory was dead or at least in great doubt. This alarm was with good reason. By measuring the speeds that galaxies travel today, and the distance that matter must have traveled to form such structures, astronomers can estimate how long it took to build these complexes, how old they are. The answer to the latter is, roughly 60 billion years. But the Big Bang theory says that the universe is between 10 and 20 billion years old. The existence of objects older than the Big Bang is a direct contradiction to the very idea that the universe emerged suddenly in a great explosion. This age of the universe crisis is rapidly worsening because the theoretical estimate of that age is shrinking by the month. Astronomers have known since the 1920s that the farther away a galaxy is from us, the faster it seems to be moving away. From this basic fact, astronomer J Lerner first proposed that, at one time, all matter was squeezed together and exploded outward in a giant explosion at the Big Bang. As we shall see in Chapter 6, this is by no means the only possible explanation. Big Bang theorists therefore argue that by measuring the distance to galaxies, and their velocities today, we can determine the time since the Big Bang and the age of the universe. Now, measuring distances to galaxies is difficult. Some standard candle that is of a known brightness must be used so that, from its apparent brightness here on Earth, the distance to the galaxy can be determined. In the past year, many different such estimates have seemed to converge on an answer. The time since the Big Bang, according to these observations, is at most 13 to 16 billion years. While this may seem like a long time, for astronomers it is uncomfortably short. Astronomers agree that they know enough about the stars to measure their ages when they are gathered together in globular clusters, spherical balls of hundreds of thousands of stars in our own and other galaxies. The oldest such clusters in our own galaxy are at least 15 to 18 billion years old, close to or beyond the maximum that Big Bang estimates of the age of the universe allow. The matter is worse than that, however. As will be explained in Chapter 1, cosmologists have predicted a density for the universe that is 100 times greater than the density that astronomers observe from counting galaxies. This hypothetical dark matter is essential to the Big Bang. But so much matter would, in the Big Bang theory, slow down the expansion of the universe. In the past, the expansion would have been faster, and thus the age of the universe even shorter, some 8 to 11 billion years. So not only are the great supercluster complexes some 5 times older than the age of the universe, even humble stars in our own galaxy are some 4 to 7 billion years too old. What has been the response of cosmologists to this age crisis? Characteristically, there has been no consideration of the idea that the Big Bang theory itself might be wrong. Instead, there have been two general approaches that maintain the faith. On the one hand, many Big Bang proponents simply say, yes, it's true that we can't explain the large-scale structure, but this is a mere detail that doesn't affect the validity of the Big Bang itself. This is much like a fundamentalist saying, yes, it appears that mountains are millions of years old, but this is a mere detail that doesn't affect the idea that the Earth is 6,000 years old. It is simply an abandonment of the idea that scientific hypotheses can be tested against observation. The second, and increasingly popular approach, is to add new hypotheses, something Big Bang cosmologists are fond of doing. See Chapter 4. The latest idea is somehow to push the Big Bang farther back in time by maintaining that expansion was slower in the past. Cosmologists theorize that a cosmological expansion force of unknown origin is speeding up the expansion. But such an accelerating force, aside from being entirely plucked out of the air, created conflicts of its own with observation. Not only has the age crisis worsened in the past year, but an entirely new problem has arisen for the Big Bang. The only quantitative predictions of the Big Bang are the abundance of certain light elements, helium, lithium, and deuterium, the heavy form of hydrogen. The theory predicts these abundances as a function of the density of matter in the universe. In the past, these predictions seemed to accord reasonably well with observation, and this was considered a key support for the theory. See page 153. But beginning in April 1991, a growing number of observations showed that these predictions too were wrong. There is less helium in the universe than the theory predicts, and far less deuterium and lithium. Figure 1. One can fit the amount of helium observed with one assumed density, deuterium with another, and lithium with a third, but no single amount of matter comes out right for all three. In particular, if helium is right, no more than 23% of the universe, then deuterium is predicted to be 8 times more abundant than is observed, 16 rather than 2 parts in 100,000. This is another fundamental challenge to the Big Bang, for with these light elements out of agreement with the theory, there is no single piece of data that theorists can point to as confirming the theory. Of course, again there have been efforts to fix things up. Perhaps nearly all the deuterium was burned up in stars, so only 1/8 is left, some cosmologists argue. Perhaps there were little lumps in the Big Bang, so that different amounts of elements were created. But none of these fixes can account for all the data. The COBE observations, announced in April 1992, had absolutely no impact on any of these problems. COBE detected fluctuations of 1 part in 100,000 in the smooth cosmic background radiation. According to Big Bang theory, these fluctuations are relics of similarly subtle variations in the density of matter soon after the Big Bang. Such fluctuations, the theory states, gradually attract matter around them to become large structures in the universe today. But this in no way explains how the structures could have grown fast enough, nor how the universe could be younger than some of its own stars, nor why the light element abundances are all wrong. Nor did Big Bang theorists even accurately predict the magnitude of the fluctuations. Original Big Bang predictions in the 1970s said that fluctuations of 1 part in 1,000 would be needed for matter to condense into any structures at all, even relatively small ones like galaxies. This is 100 times larger than the fluctuation that COBE found 20 years later. When these larger ripples they predicted were not found, theorists decided that matter must be 100 times denser than observation indicated, so that a stronger gravitational force could speed the growth of structures. See page 33. This was the famous dark matter. But with this dark matter, predictions became flexible enough to fit nearly any result. In the months before the COBE results were announced, Big Bang predictions ranged from fluctuation of a few parts in 100,000 to a part in 10 million, 100 times smaller than the COBE results. Since no COBE result could contradict this shotgun pattern of predictions, none could confirm them either. The results didn't even prove that the cosmic background is indeed an echo of the Big Bang. Other scientists, including myself and Dr. Anthony Perrott of Los Alamos National Laboratory, have hypothesized that the background is the glow from a radio fog produced in the present-day universe. Irregularities in this fog would produce fluctuations of just about the size observed, as we predicted prior to these results. And other observational evidence backs up the idea that such a fog exists between the galaxies. See page 276. Then why was there such a celebration of the COBE findings? To most cosmologists, who have spent their lives elaborating the Big Bang theory, it has become an article of faith, not a hypothesis to be proved or disproved by the evidence. After 2 years in which every new observation produced a new contradiction, the COBE results, which did not contradict the theory, indeed could not have, were seized upon as a way to defend the faith. Cosmologists loudly proclaimed that none could now question their theory. The press took the cosmologists, the existing authorities, at their word. None seemed to have doubted the overblown claims, questioned exactly how these ripples dispelled all the theory's problems, or asked any of the dozens of critics of the theory to comment. In an uncertain time, journalists were all too willing to report that the authorities had the cosmos well in hand, that final truths were now known, that science and religion spoke with one voice. This new entanglement of science, authority, and faith, this attempted scientific counter-revolution, is dangerous to the whole scientific enterprise. If the wildest theoretical claims are accepted on the word of scientific authority alone, the link with observation is broken. And if appeals to authority extend to Scripture, if one accepts that proof of the Big Bang is proof of one variety of Judeo-Christian doctrine, then attacks on this scientific theory become heresy, as Galileo's attacks on Ptolemy were deemed 400 years ago. This is a return to a cosmology built on faith, not observation, a trend that is a major theme of this book. Fortunately, this is not the only trend in cosmology. The publication of the first edition of this book in May 1991 has considerably sharpened the cosmological debate and brought this debate to the attention of a broad audience outside the narrow confines of cosmology itself. The idea that there is a scientific alternative to the Big Bang has now been discussed on the editorial page of the New York Times, in popular astronomy magazines like Sky and Telescope, on scores of radio stations, and on several TV news shows. In the past, Big Bang cosmologists have simply ignored the theory's critics. Now they are reluctantly beginning to debate with these critics. Perhaps most important, Big Bang supporters have had to take the challenge we pose seriously in their own scientific circles. At a recent seminar by a leading cosmologist at Los Alamos National Laboratory, the speaker began by raising this book and assuring his audience that the Big Bang was still valid. When I gave a seminar on the failure of Big Bang cosmology and the plasma alternative at Princeton University, several leading researchers and their flock of graduate students attended. Significantly, in the discussion that ensued, there were few defenses of the Big Bang, and the cosmologists' comments focused on their criticism of plasma cosmology. When I remarked on this, one Big Bang supporter shrugged and said, "We all know that the Big Bang has many problems. But if there is no alternative, we must stick with it." Today, this debate is only beginning to be reported in the popular press and in the scientific journals. Yet it is nonetheless occurring and growing. This book is a report on that emerging debate, its roots, and its consequences. And since, as history abundantly shows, people's views of the universe are bound up with their views of themselves and of their society, this debate has implications far beyond the realm of science, for the core of the cosmological debate is a question of how truth is known. Must we rely on experts, whose pronouncements, no matter how seemingly absurd, are accepted on faith, or do we trust in the evidence of the senses, in our observation of the world? This question is also at the center of today's social events. As I write, there is not a government east or west that today enjoys the confidence of its people or that can credibly promise them any improvement in their future. The global decline of production and standards of living, begun 20 years ago, has accelerated. To extricate society from this whirlpool, must we rely on the experts who, east and west, call insistently for policies that benefit the few and sacrifice the many? Or can we rely on our own judgment to take into our own hands the hands of those who work at the direction of society, and of the economy that supports that society? How these questions are answered will shape not only the history of science, but the history of humanity. Eric J. Lerner. May 1992. Page 20.